Here's a 12-lead electrocardiogram of a CARS member. This CARS member looks well, isn't having a heart attack, okay? Might be slightly crazy like most of us, but is not having any cardiovascular problems. If we start the algorithm and ask the first question, is ST elevation of at least 1 to 2 millimeters present in two anatomically oriented leads? We look at the 12-lead ECG and in fact do not see any leads that have significant ST elevation. So we will answer no to this question. Because we answer no to this question, we can no longer use the algorithm and will be forced to diagnose the lack of STEMI in this patient. In fact, this is a normal electrocardiogram. This patient is not having a STEMI. Let's go to another example. Here's a slightly more dramatic ECG. Again, an adult with chest pain that we're concerned may be having a heart attack. We ask the first question, is ST elevation present in at least two leads? The answer to that question is yes. If we look in leads 2, 3, and AVF, we see significant ST elevation. So we will answer yes to question 1. The next question, is the QRS complex normal size in lead V1 and or V2 as well as V5 and or V6? Remember, we are looking for the negative part of the QRS complex in V1 or V2 plus the positive part of the QRS complex in lead V5 or V6. If we add these up, they must equal less than 35 millimeters to qualify as normal. On this particular example, we have 5 and approximately 2 more, so 7 millimeters of negative QRS in V1 plus 5, almost 10 millimeters of positive QRS in V5. If we add those two numbers together, they will be less than 35. So the answer to this question is yes, the QRS complex is a normal size. The next question asks us, is the QRS complex a normal width? We need to look very closely here and remember that one small box is equal to 0.04 seconds, while one large box from here to here is equal to 0.2 seconds. So we're asking the question, is this QRS complex more narrow than two small boxes or 0.08 seconds? And the answer to that question is yes, it is normal. The last question, is ST segment depression also present on this ECG? The answer to that question is yes. We see ST depression in leads 1 and AVL as well as lead AVR. The answer to all 4 questions is yes, and when that occurs, you have an ST segment elevation myocardial infarction. The next example, do we have ST elevation in at least 2 leads? The answer to that question is yes. Look at leads V1, V2, and V3. We have elevation in all 3 leads. Next question, is a QRS complex normal size? Remember, we will look at the negative part of the QRS in V1 and the positive part of the QRS in V5 or V6. Let's add these up. 5, 10, 15, 18, probably 4, so 22 for the negative part of the QRS in V1, plus 5, 10, 15, 21 plus 4, 25, 25 plus 22 is greater than 35. So the answer to question 2 is no. The QRS complex is not of normal size. Because we have answered no to this question, we cannot use this algorithm, and we cannot diagnose STEMI in the out-of-hospital setting. This ECG, in fact, does not demonstrate STEMI, but demonstrates ST elevation related to left ventricular hypertrophy. Isn't this fun? The next example, do we have ST elevation in at least 2 leads in the same region? And the answer, of course, is yes. Looking at leads V1 and V2, and perhaps even V3, we have elevation of at least 1, if not more, millimeters. So the answer to question 1 is yes. Question 2, is a QRS complex of normal size? we're going to have to add this up because it may be close. The negative portion of V1 is 5, 10, 15, perhaps one more, 16, plus 5, almost 10. 16 plus 10 is 26. The curious complex size is normal. It's large, but normal. So the answer to question 2 is yes. We move on to question 3. Is a curious complex normal width? Remember, we were looking for no more than 2 small boxes. Let's look at lead V2. This curious complex is at least 3, if not more, small boxes in width. So it is abnormally wide, and we can't say yes to number 3. In fact, the answer is no. Because the answer is no, we cannot rule in STEMI in the prehospital setting. This 12-lead ECG demonstrates a left bundle branch block pattern. Another case of a patient with chest pain. Is ST elevation present in at least 2 leads? It is. Look at leads 2, 3, and AVF. ST elevation is in fact present in these 3 leads. So the answer to question 1 is yes. The next question, is a curious complex normal size? Adding the negative portion of the curious in V1 plus the positive portion in V2 gives us approximately 25 millimeters of curious complex size, meaning that it is normal. So the answer to question 2 is yes. Question 3, is a curious complex normal width? Yes, it is. It is less than 2 boxes wide, allowing us to answer yes to question 3. And then question 4, is ST segment depression present? And again, the answer to that is yes. In leads 1 and AVL, as well as lead V2, we do in fact see some ST depression, which remember is also called reciprocal change, allowing us to answer yes to that question and ruling in an inferior STEMI. Another challenging ECG. Is ST elevation present? Yes, it is. Leads V1, V2, V3, V4, V5, and perhaps even V6 have ST elevation. The answer to question 1 is yes. Okay. Is a curious complex a normal size? Curious complex is in fact quite small in V1 plus V6, so we can say that the answer to that question is yes, it is normal size. Is a curious complex a normal width? It's getting close, but if you look closely, it is probably slightly less than 0.08 seconds. So the answer to question 3 is again, yes. Is ST segment depression present? No, we don't see it on this ECG, so we can't say reciprocal change is present. So the answer to question 4 is no. So, can we diagnose STEMI in the prehospital setting? Based on this algorithm, we can't, even though this does show a large anterolateral STEMI. Remember, I told you early in this slide set that this algorithm is not intended to diagnose all STEMIs, but most. Because no reciprocal change is seen in this ECG, it makes it more difficult to diagnose STEMI for those providers that are just beginning to interpret the ECG. Now, if you're a more experienced provider and are comfortable diagnosing STEMI, you can certainly do that here. The value of question 4 helps us rule in STEMI to a very high degree of certainty, but the lack of a positive answer to question 4 doesn't mean that STEMI is not present. Yet another patient with chest pain. How many calls are you going to get today for chest pain? We asked the first question, is ST elevation present in at least 2 leads? Yes, it is. V1, V2, V3, V4, V5, V6, as well as leads 2, 3, and AVF all have ST elevation. So we can easily answer yes to question 1. Is a curious complex normal size? It's close, but if we add up the negative portion of the QRS here, we get approximately 20 plus here approximately 10. So we are close to 30 millimeters, but we are definitely less than 35 millimeters. So we can say that the Kuros complex is a normal size. Is the Kuros complex normal width? Yes. Look at the QRS. It is less than 0.08 seconds in width. We can clearly say that we have a normal Kuros width. The last question, is ST segment depression present in at least one lead? No, there is not a single ECG lead that demonstrates ST depression. So we can't again diagnose STEMI on this. And that's a good thing, because this is not STEMI. This ECG pattern demonstrates benign early repolarization. Benign early repolarization, or BER, is a normal variant pattern. That means it's not abnormal and can be seen in patients that are entirely healthy and not having any problems of any sort, including heart attack. Here the algorithm helps us by ruling out STEMI in this case and not subjecting the patient to unnecessary therapies, etc. Okay? And the value of the fourth question, is ST segment depression, is illustrated here. So we will end this slide set. I very much appreciate your time, and if you have questions, please do not to contact me by email, phone, or in person, and I would be very happy to talk to you in more detail. Thank you very much. I appreciate your work with patients, and good luck in the field.